Hey guys, in this video we're going to be talking about pipelining. So if you do not understand pipelining or if you do not understand single cycle data path, I recommend you to go back and review that because in this example we're going to be talking a lot about pipelining and referencing back to the single cycle data path. So in pipelining, let's go ahead and pull this chart out. In pipelining, we have five stages. So we have I-fetch, which is instruction fetch. We have decoding, we have execution, we have memory, and we have write back. And the way the cycle works, which is necessary for this example, is cycle one. You're going to look at all the instruction that is being evaluated on their cycle. So as you can see, it's in cycle one. The first instruction is in I-fetch. In cycle two, the first instruction is in decoding and the second instruction is in I-fetch. And cycle 3, first instruction is in execution, second instruction is in decode, and third instruction is in I-fetch, and so on. So now you get in cycle 6, you have second instruction is in write back, third instruction is in memory, where right here first instruction is already ended in cycle 5. Okay, so let's go ahead and go to our example right there. Let's go and pull this up. So over here we can see the how the first instruction is being evaluated. So instruction fetch, instruction decode, ALU, mem, and write back. So we know that the first instruction ends by the fifth cycle. Let's go ahead and see what this question is asking first. So we have 6 or 7 instruction so far, and it's asking what is the pipeline control unit control inputs are going to be for clock cycle 7 right here. So let's go ahead and see what these instructions are doing. So on the fifth clock cycle, this instruction should be gone, so we don't really care about this instruction. And then by the sixth clock cycle, this instruction is also going to be gone, so we don't really care about this instruction either. However, this instruction ends in seventh clock cycle. So during clock cycle 7, this instruction going to be in the stage called WP. Okay, so where is WP and where is mem? Where is execution? Where is instruction decode and fetch? So right here I went and initialized it already. So write back is going to be right here. Memory is going to be right there, which is right in between write back pipeline and write back memory pipeline and execution memory pipeline, my bad. Execution is going to be right in between these. Execution right here is going to be right in between these. So this is the execution stage, and then this is the instruction decode stage, and everything left of this pipeline is going to be instruction fetch. Okay. All right, so let's go ahead and see what the control unit is. The thing about control unit is whenever you're deciding what each control units are going to be or control signals are going to be, you want where the control unit is coming from. So for example, this control unit right here. See, even though it is at instruction decode stage, it is actually coming from write back stage. So as you can see, it is coming from write back stage. So that's just an example of control units can come from anywhere. We care about where it's coming from. The value for the control is going to be coming from its value for the control is initiated wherever the signal is coming from rather than where the signal is going to. So this is just a simple example. So for write back stage, we know we have add T5, T4, and S4 for our write back stage. So this is write back. So let's go ahead and see the controls for that. So over here, what add is doing is add is going to be adding T4 with S4, and T5 is going to be equal to that. So that is definitely writing something on the register. So over here, this is our register write. So this is going to be 1. And over here, mem to register, we know add mem to register is going to be 0 because we want the value from the ALU. We want the value from the ALU rather than the value from the memory. So this is going to be 0. Okay, so let's go ahead and move on to memory. So in this stage, we know the next instruction, which is add, that is going to be in the memory stage. So let's go ahead and unhighlight this right here because now we're interested in the memory stage. So this is the memory stage right there. So the next instruction automatically, because we're going backwards rather than forward. Okay, let's go ahead and name this our memory stage. Here we go. All right, so this is what we want. We want add. And again, add is going to be T6 is going to be equal to T9 plus S4. And for this example, guys, I know you guys are thinking about data hazards, maybe, and then forwarding unit. For this example, imagine none of this really, we don't really need any of these because all these instruction, for example, T9, this is not really T9, this is not really T7, and then so we're not really using forward. We don't really need forwarding unit or the hazard unit. So which is this is going to be a much more advanced material. So we're just this is just the initial part of the pipelining. So just don't worry about hazard unit or forwarding unit right now. So let's go ahead and find the control unit for add. So this is in the memory unit. So in memory we have three things. We have memory write, memory read, and we have branch. So we know that this is an add instruction. This right here is an add instruction. For add instruction, we're not going to be using data memory at all, actually. So we're not using data memory at all. So this is going to be 0. Memory write is going to be 0. So as memory read. Memory read is also going to be 0. Let me go ahead and remove this line right here because that is kind of confusing. And so memory write is going to be 0. Memory read is going to be 0. And we're not branching anywhere either, matter of fact. So this is going to be 0 as well. Let's go ahead and remove that line because that is kind of confusing as well. Okay, that's just for clarification. And interesting thing is, see, there's another output from the adder that is going that actually is going to the PC. This is going to be PCSRC input. That is just deciding where the next PC address should go to. So this is also going to be 0 because we know that adder we need a 1 1 for the adder for the output to be 1. But since this is a 0, adder is never going to be 1. So let's go ahead and put 0 right here. Okay, great. Okay, next up we have our execution cycle. So this is execution right here. So let's go ahead and unhighlight this part right there. Now we're interested in our execution. We know the next instruction is going to be our execution instruction. So let's go ahead. I'm just going to denote it as E. Okay. And let's go ahead and highlight that. So this is store word. So what does store word do in execution? So for that, this is a little bit more complex than adder. So we can go ahead and pull up our table that we can find in the book. So right here we have the store word. So as you can see in the execution part, let's go and change this cursor right here. In the execution part, we need ALU op, we need register destination, and then we need ALU SRC. And because we can find this instruction in our table, we can easily find that ALU SRC is going to be 1. So let's go ahead and put 1 for ALU SRC. And then ALU op is going to be 0 0, and that is correct. ALU op is 0 0. So let's go ahead and put 0 0 for ALU op. Let's scroll down a little bit to find register destination. We know register destination is going to be don't care. So absolutely, because store word is not writing anything on the register. So let's go ahead and find this. So register destination is also going to be, actually it's going to be don't care. So it's the X. Okay. All right, moving on to the instruction decode stage. So we know after that, this instruction is going to be instruction decode. All right, let's go ahead and highlight that as well. Highlight that part. This is our instruction decode phase. So as you can see, S3A T2, and we know that S3 is actually an RT value, honestly. So over here, but notice that over here we're not really asking for the mux values. We're actually asking for the immediate value, and we know the immediate value is 8. So this is 8 right here, so the immediate value is actually 8. So that's all we're asking for in this instruction. So over here the immediate value is 8 and nothing else, so don't worry about anything else. And the interesting part is, even though the next value is this value right here, this sub value, this value is sub instruction. Sub, that's not a value, actually that's the instruction. My fault for saying a value. So this is going to instruction fetch for in cycle 7. So this is sub. For that value, this is, I mean, for that phase, this is sub. So